Okay, we're in your third lesson. In this lesson, you are going to plot points in the Cartesian coordinate plane. You're going to use the distance formula to find the distance between 2 points in a coordinate plane, and we're going to use the midpoint formula to find the midpoint of a line segment. We're going to determine whether a point is a solution of an equation. We're going to sketch the graph of an equation and find the x and y intercepts of a graph of an equation. We're going to determine the symmetry of a graph as well. This video is probably going to be 2 parts, so make sure that after you watch this video to watch the second. I try to make them each video under 15 minutes. So let's talk about one of your objectives, and that is to find the distance between 2 points and the midpoint between those points. So we have the distance formula right here. And where do formulas come from? Were they just given to us from some unknown book? No, they're discovered in a sense. So here's the distance formula. So let's find the distance of these 2 points, and then I'm going to explain to you where that formula comes from, okay? So we're going to just copy what we have here. D is distance. We're going to rewrite the square root. X2, X1. So we're going to label this X1, it's your first X, and X sub 2, because it's a subscript. That's your second. And then Y1, Y2. It really helps to label everything. Don't be above that, or don't try to provide shortcuts because you'll mess up, okay? So X2 is 3 minus X1, which is -2. Be careful with those negatives. Squared plus 4 minus 1 squared. And I'm just going to rewrite it. 3 minus -2 is a positive 5, plus 4 minus 1 is 3. Now I'm half tempted to do this in my head, but to be precise, I'm going to write everything out. And it's the square root of 34. Okay, you can leave it like that. If the directions say round to the nearest 10th, then no, you need a decimal. But we don't really say the square root of 34. When I put it in my calculator and press enter, you're gonna get about, the distance would be 5.83. I just usually tend to go to the nearest hundredth spot. Okay, so your distance is almost 6. Now, where did the distance formula come from? So let's go back to Pythagorean theorem. Okay, I'm doing this one-handed because I'm filming, so don't mind me. And we said a squared plus b squared equals c squared. Do you remember that? Okay, well, if we wanted the distance between these 2 points, c, how would we get it? Well, if we want to find simply c by itself, we got to get c by itself. So this is to find the distance, but then when you get to the end, you always get like a number like 100, and you have to take the square root to find the actual distance of c. So we take the square root of both sides, and your distance, or c, equals the square root of a squared plus b squared equals c. Now, we're not writing a, we're writing x2 minus x1. Well, a is the distance between 2 things, and same with b. You could make this a and this b, it doesn't really matter. They're both legs, okay, of a right triangle. So we could call this x2 and x1, they're both x's. How do you find the distance between 2 things? Subtract them. So that's where this comes from. Okay, and they're just replaced. So that's where your distance formula comes from. So this is how you find the distance. All right, midpoint formula, you have to find the middle of these points, or the averages. Well, how do you find the average of something? If there's 2 things, to find the average, you add them together and divide by 2. So for a midpoint formula, you take your x's, add them together and divide by 2. And then to find your y value, you add your y's together and divide by 2. Okay. And we're making this a coordinate because we're finding a midpoint. So your x value is -2. Your y value, or I'm sorry, your x2 value is 2, 3. And then just do the same thing with y. So you're going to get -2 plus 3, which is 1 over 2. And 1 plus 4 is 5 over 2. You can leave it like that, or you can make it 2.5. Now, a good way to check, if you're really unsure, just quickly graph it, see what it looks like. So let's start with -2, 1 as our first point, and 3, 4 as our second point. Okay, so the distance from here to here, here to here, here to here is what we're finding. So the distance here, the distance here is 1, 2, 3, 4, 5. The distance here is 1, 2, 3. And we calculated that the distance was 5.83. Would that be logical? Well, yeah, your hypotenuse is your longest side. It's longer than 5, but it's not a ridiculous amount, so that seems appropriate for distance. And midpoint, let's try it again. -2, 1, 3, 4. If we were to find the midpoint, it should be right around here. Well, our midpoint is 1/2, and then up 2.5. Yeah, that seems appropriate. So we did it right, okay? So that's a lot for your first example, but that's how you do it. It's pretty simple. It's a good reminder of Algebra 1 and a little bit of geometry. Example 2, determine whether -1, 0 is a solution to this equation. Y equals 2x squared minus 4x minus 6. Well, -1 represents an x value and 0 represents a y value. So if they represent those values, substitute them in. So wherever I see y, I'm going to replace it with 0. And wherever I see an x, I'm going to replace it with -1. And what am I going to do with these? Well, if I replace them, and they are in fact a solution, then I will get a true expression or equation. So if I simplify, is 0 equivalent to all of this? Well, -1 squared is 1. -4 times -1 is +4. Let's keep going. 2 plus 4 minus 6. 0 equals, well, what's 2 plus 4? 6 minus 6. Is this true? Does 0 equal 0? Yeah, that's true. And it just doesn't have to be 0. What if I got like 7 equals 7? Or 3 equals 3? Or -2 equals -2? If it's a true equation, okay, and they're equivalent, they're equal to each other, then that means that that coordinate is in fact the solution. Okay, so therefore, -1, 0 is a solution. Okay, we try to be professional here. All right, intercepts of a graph. So if you're given a graph, you can be given all types of graphs, okay? You could be given a circle graph. You could be given a quadratic. You could be given a linear equation, okay? And it's talking about x and y intercepts. So the x-intercept of a graph is when the graph intersects at the x-axis. Here's an x-intercept. Here's an x-intercept. Oh wait, this one doesn't have it. That's okay. Sometimes you might have an x-intercept. Sometimes you might not. The y-intercept of a graph are the points at which they intersect the y-axis. Here's a y-intercept. Eventually we'll get one. And we don't have one here. That's okay. So you've seen this before, but we're going to find x and y intercepts by not just using a graph, but using algebra. So here, if we notice x and y intercepts, every time you see an x-intercept, what's your y value? Did you go up? Did you go down? No, you didn't go anywhere. So to find x-intercepts, let y equal 0 to find x. Man, this typing's off. I'm going to edit this before I upload it. Okay, to find the y-intercept, did you go left or right? No. So your x value is actually 0. And then you just have your y value. So find the x and y intercepts and then graph each equation. Okay, so I'm just going to make up something. Let's do y equals 4x plus 1. Okay, so to find the x-intercept, let y equal 0. So we're going to put 0 in for y, and then we're going to find x. Subtract 1 from each side. Divide by 4. Yeah, if you need to do the minus 1, that's fine. If you need to do divide by 4, that's fine. Okay, so your x-intercept is negative 1/4. All right, let's find our y-intercept. To find your y-intercept, you put 0 in for x. Now we need to find y. So y equals 4x, which we said is 0 plus 1. Y equals 0 plus 1. Y equals 1. So if I were to graph this, because I said to graph each equation, you go to 0, 1, and negative 1/4, 0. There's your equation. Okay, so that might be a little more complicated, so make sure you do your homework and ask those questions in class. Okay. You know what, let's just go for it. Let's just try to make it all one video. We're almost done. All right, now we're gonna talk about symmetry. So we have a graph that's symmetric to the x-axis, the y-axis, and the origin. So what would that look like? Something symmetric to the y-axis means that whatever it looks like on the one side, it's gonna look like the same on the other. So that'd be symmetry to the x-axis. This would be symmetry to the y-axis. It means what it looks like on one side, it look like on the other side. And symmetry to the origin, what it looks like on one side, looks like on the origin the other side. Sorry, I should look more like this. Okay.